So today's lesson is on rational exponents. We're starting our unit on exponential and logarithmic functions. And we need to discuss a little bit more exponents. Up to this point, you guys have only had integer exponents. So integer exponents are when you have, obviously, an integer in the exponent. So something like 5 to the power of 2 or 6 to the power of negative 3. These are integers. Remember, integers are like negative 6, negative 5, negative 4, 0, 1, 2, 3. They don't include fractions and they don't include decimals. So now we're going to extend our exponents to have rational exponents. And rational. So rational numbers, remember, are numbers that can be made into fractions. So basically we're talking about fractional exponents, 5 to the power of 1/2, 6 to the power of negative 2/3, things like that. A rational number are numbers that can be made into fractions. Okay, so knowing that, let's start looking at what happens with rational exponents. So we're going to start out with a definition. Basically, the definition says that if you have a to the power of, let's say, p divided by q, the top number represents your integer exponent and your bottom number represents the root. So this is the qth root of a to the power of p, which is the same thing as the qth root of a all to the power of p. So a short way to remember it is the number on bottom ends up being the root, and the number on top ends up being the power. Okay? So you guys know I like to color code. So the number on top is your power. The number on bottom is your root. All right, and a is still your base. So I'm just going to go through 4 examples here. If you want to just look in your book, these are the exact same examples as are in your book. If you want to just read it instead of listening to the lecture, you're more than welcome to do that. So example 1 says simplify 16 to the power of 3/4. So first what I'm going to do is I'm going to rewrite this. 3 is my power, 4 is my root. Now I always say a good rule of thumb is do the root first. Do the root first. You don't have to, but doing the root first will make your number smaller and you'll be able to do mental math a little bit easier. So I'm going to rewrite this as the 4th root of 16 all to the power of 3. Well, what's the 4th root of 16? 2. 2 times 2 times 2 times 2 is 16. So that means this is 2 to the power of 3. And what's 2 to the power of 3? 2 times 2 times 2 is 8. So we get 8. And that's our final answer. So all I'm doing is I'm using the same concepts as above. Remember, the top number is my power, and the bottom number is my root, right, the 4th root of 16. So example number 2. This one says simplify negative 25 to the power of positive 25 to the power of negative 3/2. So first thing I'm going to do is I'm going to rewrite this with a positive exponent. Remember, our rules of exponents say that If you have a negative exponent, you can make it positive by pushing it to the other side of that division side, or the other side of the division. So I'm going to write this as 25 to the power of 3 halves. Now remember, the number on top is your power, the number on bottom is your root. So here's my root, here's my power. So I'm going to rewrite this as 1 over the square root of 25, all to the power of 3. That's 1 over square root of 25 is 5. And 5 to the power of 3, well, 5 times 5 is 25. Times 5 again is 1 over 125. And there's your final answer. Example number 3. Remember, we're doing 4 examples. Actually, there's a part B to this one. Let's do the part B to this example too. So we'll do 5 examples. Simplify 9 to the power of 2.5. Well, first I'm going to rewrite that as a fraction, so I know what's my root and what's my power. So that's the same thing as 9 to the power of 5 over 2. So I now have my power and my root. I rewrite it, and it becomes the square root of 9, all to the power of 5, which is 3 to the power of 5, which is 243. And there's your final answer. Next example. There's 2 to this one also, 2 parts. So we'll say this is the cube root of a to the power of 5, b to the power of 3 divided by c squared. And the directions say write in exponential form. So right now we have it simplified in radical form. I want to go backwards and write in exponential form. So I know cube root of 3. 3 must be in the denominator, so that's like to the power of 1/3. I'm going to rewrite this. A to the power of 5, b to the power of 3, c squared, all to the power of 1/3. Properties of exponents tell me that I can now multiply this 1/3 into all of my exponents. So that becomes a to the power of 5/3, b to the power of 3 over 3, c to the power of 2/3. And I can just quick simplify my b. And so that becomes a to the power of 5/3, b, c to the power of negative 2/3, or a to the power of 5/3, b divided by c to the power of 2/3. These are the same thing. One has all positive exponents, the other has a negative exponent. Next example, simplify 1 over the 3rd root of 4 to the power of negative 3 halves. Okay, well, I'm going to make this exponent positive by moving the denominator to the top and the numerator to the bottom. So this becomes cube root of 4 over 1 to the power of positive 3 halves, right? I'm just switching them to make the exponent positive. Now I'm going to rewrite this as 4 to the power of 1/3. Divided by 1 is just 4 to the power of 1/3, so I'm not going to divide by 1 to the power of 3 halves. Properties of exponents say I can multiply my exponents here. So that gives me 4 to the power of 3 over 6, which is 4 to the power of 1/2. Now, what's 4 to the power of 1/2? Well, that's the same thing as square root of 4. And what's the square root of 4? 2. So there you go. Last example. Write square root of 8 times cube root of 4 in exponential form and in simplest radical form. In exponential form and simplest radical form. So I'm going to start out by writing them in exponential form. So this becomes, let's see here. Oh, there's a little bit of a trick on this one. So square root of 8 is the same thing as 2 square root of 2. Actually, let me think about this again. That's not how I want to do this. Because I want to be able to combine these together, I want them to have the same base. So I'm going to do a little trick here. I'm going to rewrite 8 as 2 cubed. So this is the same thing as this. And I'm going to rewrite 4 as 2 squared. So it's a little trick. I want them to have the same base so that I can multiply them together. So square root, same thing as 1/2. So this becomes 2 to the power of 3/2 times 2 to the power of 2 to the power of 1/3. Okay, the square root, same thing as power of 1/2. I could rewrite this. Maybe it makes it a little clearer if I do it in 2 steps. 2 to the power of 3 to the power of 1/2. Square root, same thing as power of 1/2. Now if I multiply my exponents, I get 2 to the power of 3/2 times 2 to the power of 2/3. These have the same base, so what can I do with the exponents? So I can add them. Add exponents. 3/2 plus 2/3, get a common denominator. So times 3 times 3 times 2 times 2, oops, that's 9/6 plus 4/6, which is 13/6. So this becomes 2 to the power of 13/6. And here is your answer in exponential form. Now if I want to write this in radical form, that means this to go away. So for radical form, I'm going to take this answer, 2 to the power of 13/6, I'm going to rewrite it. This becomes 2 to the power of 13. Oh, don't want this. Go away. So it becomes 2 to the power of 13, and then the 6th root. So that means I have 13 sixes. 1, 2, 3, 4, sorry, 13 twos. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, put them all there. And it's the 6th root. So I'm looking for a group of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So to simplify, this actually becomes, out comes a 2 and out comes a 2. So I get 4 6th root of 2. And this would be my answer in radical form. This is a little bit trickier. So going back to the beginning, what I did was I wanted them to have the same base, so I rewrote 8 as 2 cubed. I rewrote 4 as 2 squared. I rewrote my radicals as exponents, and then I simplified. Okay, I took my answer here, I rewrote it in radical form, and I simplified my radical. So you guys should be good from there. Should be able to do your homework. We posted an answer key online, so hopefully that helps you out with your homework. And sorry I can't be in class, but I know you guys will be fine.